Here we have a really interesting page of notes that is going to show us our relationship between the electric field and the current density. We start off with just delta V equals E times L. And to remind you where that comes from, that really is voltage equals ed, right? So it's negative integral E dot ds, and that could become ed if the ds is the d. And remember, we play a little fast and loose with our negatives. For Ohm's law, the delta V is always a voltage drop. Right? And normally it's V equals IR. I've specified it as delta V here for us explicitly to set 1 and 2 equal in a moment, as we will see. But really it's this delta V equals negative integral E dot ds, which gives us the delta V equals the E times L, the length of the wire. And we have Ohm's law, V equals IR, and we also know that J equals IA, so I equals J times A, and substitute that in. So delta V equals JAR, jar. Delta V equals EL, so as I have here, when we set 1 equal to 2, we get electric field times the length of the wire equals current density, cross-sectional area of the wire times R. Easy to remember, boxed equation, so we do want to memorize this. If you're Spanish, it's el jar, the jar. So el jar will be a useful equation for us as we go forward. And it turns out that we can even, as you can see here, have a really neat kind of relationship appearing between the electric field and the current density. When we plug in for the resistance, resistivity length divided by area, we lose the L, we lose the A, and we're left with EJ rho. Well, we know that the electric field is a vector quantity. So that means we need a vector quantity on the right-hand side, and as it turns out, we know that J is a vector quantity, resistivity is not, and E equals rho J, as it says here, really important. So please make sure you get this down into your notes. We've now established this classic F equals ma, as we've seen before, cause and effect. Force is the cause, acceleration is the effect we observe. M is the inertia, the property in nature of the object that's being accelerated by the force. And here we have the same cause and effect type of relationship going on. The electric field is definitely the cause of the flowing charge. The effect we see is the charge, in this case charge per area, and the resistivity is that property of nature. Remember, we saw copper and silver had different resistivities relating the cause, the electric field, to the effect, that flow of charge, as a current per area. So really neat. E equals rho J, really important equation for us, both conceptually for multiple choice questions or for free response questions. L jar, also important. So I am zooming out, as we have done many times before, for you to pause, make sure your annotations are complete, and of course, to facilitate discussions in class.